students, welcome back to chemistry class. In the previous class we have discussed modern periodic table, and today we are continuing with the trends in modern periodic table. Okay, students, the elements which are present in the periodic table are showing different properties in group wise as well as period wise. Okay, that are the trends in the periodic table. Okay, and today mainly we are going to discuss the trends like first valency, and the second atomic size, third it is metallic character, and the fourth electron negativity. Electron negativity. This many points we are discussing today. Okay. So before that, let us go to the period group wise first. Okay. When you take the group wise, you can see there are 18 groups are present. Okay. What happened to the valency in a group wise? So before that, what is valency? Valency is the number of electrons. Number of electrons which are present in the outermost shell to complete the object. Either it can be shared, or it can be lost, or it can be gained. That are the valency of the shell, valency of an atom. Okay. So what happens to the valency in a group wise? So children, in a group wise, the valency is same. Group wise, the valency is same. How you can say valency is same? Okay. First let us take the valency. Okay, students, in a group wise, the valency is same. Okay, valency is same. And let us take the atomic number. If you take the atomic number of sodium, it is 11. So K is equal to 2, L is equal to 8, M is equal to 1. The valency is 1. And if you take potassium, atomic number 19, so K is equal to 2, L is equal to 8, M is equal to 8, and N is equal to 1. So you can see valency is 1. If you take lithium or hydrogen, if you take lithium, you can see atomic number 3, so K is equal to 2, L is equal to 1. Same valency 1. If you take hydrogen also, you can see K is equal to 1. Okay. So what you observe? In the first group, all the metals, all the elements, they are all metals, right? They are alkali metals. They are having the same valency 1. Okay. So what happens to the second group? Second group, if you check, what happens to the second group? Yes, if you take beryllium as a member with atomic number 4, right? K is equal to 2, L is equal to 2. The 2 is the valency. If you take magnesium, so with atomic number 12, right? So K is equal to 2, L is equal to 8, M is equal to 2. 2 is the valency. Or if you take calcium with atomic number 20, right? So K is equal to 2, L is equal to 8, M is equal to 8, N is equal to 2. Okay, you can see here all the elements possess the same valency 2. So the group number 2, all the elements have the same valency 2. Okay. You forget about transition metals. Now let us go to the 13th group. 13th group, if you take the first member, it is boron. Right? Boron with atomic number 5. K is equal to 2. L is equal to 3. L is equal to 3. Right? So the valency is 3. Okay. And if you go to the 14th group, that is carbon. What happens? Atomic number 6. K is equal to 2. L is equal to 4. All group members have 4 valency. Here all group members have 3 valency. But when you come to the 15th group, the 15th group first member is nitrogen with the atomic number 7. Right? This K is equal to 2, L is equal to 5. The balance is 3. 3 more electrons are required to complete the octet. So the 15th group members have valency 3. So when you come to the 16th group members, the first member oxygen with atomic number 8. When you write the electronic configuration, K is equal to 2, L is equal to 6. So the valency is 2. All the members of 16th group having the valency 2. So when you come to the 17th group, the first member is fluorine. First member is fluorine. Atomic number 9. So when you write the electronic configuration, K is equal to 2, L is equal to 7. The valency is 1. Valency is 1. And the last 18 group elements, they are 0 group elements, valency 0. So what you observe? In a group wise valency is same. In a group wise valency is same. But in a period, what you observe? First valency increases from 1 to 4. First valency increases from 1 to 4. After that, from 15th group onwards, again valency decreases. Because the first group have the first element like lithium, it is 1 valency, beryllium it is 2, boron it is 3, carbon it is 4, but nitrogen it is 3, oxygen it is 2, fluorine it is 1, and finally it is 0. Right? The first 1, 2, 3, 4, again decreases 3, 2, 1, 0. So generally you can say that the valency first increases and decreases in a period. But in a group wise valency is same. Okay. So this is the first trend, that is valency. Now let us go to the next trend, that is atomic size. Atomic size. Atomic size. Okay, atomic size means when you consider an atom. When you consider an atom, hydrogen, the first shell you can see 1 electron. So what is the distance between nucleus to last shell? That is the atomic radius. That is the atomic radius of the atom. So when we talk about the hydrogen, atomic radius is very small. Okay, but in a group, what happens to the atomic size? In a group wise, you can say that. So first it is hydrogen with 1 electron. Second it is lithium with 2 electron. After that sodium with 3 shell. After that potassium with 4 shell. Such a way there is a tremendous size increases. Sizes increases drastically. So what happens to the atomic radius? Atomic radius also you can see a large variation. So in a group, atomic size increases. In a group, atomic size increases. As a result, what happens? When atomic size increases, what happens? Atomic radius also increases. Atomic radius also increases. As a result, you can see, you know the solar system. The planet next to sun is highly attracted. But the planet which is far away from the sun is least attracted. Right? Yeah, this is what happens in the group wise. Okay. So when you come down, you can see when you reach the francium, you cannot imagine where is the shell, where is the last shell. You cannot imagine. You cannot imagine. Such a tremendous drastic change is there. Such a big size atom is there, francium. In a group wise, you can see francium is the biggest element, since it have a big atomic size and atomic radius. Okay, so what happens in a period wise? In a group wise, the number of electrons, the number of shells are more because of the atomic size. But what happens in a period wise? What happens to atomic size in a period wise? If you take the second period, first metal, first element it is lithium, can see first shell it is 2, second shell it is 1. When you talk about beryllium, here also you can see first shell with 2 electron, second shell with 2 electron. When you talk about the boron, first shell with 2 electron, second shell with 3 electron. When you talk about carbon, first shell with 2 electron, next shell with 4 electron. Students, look at here. Is there any increase in the shell? No. In a period wise, the shell, the number of shells are same. But the thing is that the number of electrons are increases one by one. 1 unit increase is there. So you can say that in a period wise, atomic size decreases, but in group wise, atomic size increases. Okay, how it decreases in period wise? Because you can see that the shells are closer to the nucleus. The shells are closer to the nucleus means the nucleus can have attraction to every electrons. Right? The nucleus have attraction to every electron. As a result, the positively charged nucleus will be attracted to all the electrons which is present nearby the shell. So as a result, there is a shrinkage in the size of the atom from left to right. So you can say that left to right atomic size decreases due to increase in nuclear charge. Due to increase in nuclear charge. But in a group wise, atomic size increases because the number of shells increases. Okay? And coming to the next trend, it is metallic character. Metallic character. Metallic character. Metallic character. What is meant by metallic character? The ability to lose electrons. That is the metallic character. What are metals? The metals are the elements which are capable to lose the electrons, or they are electropositive. There is a small connection with atomic size when you talk about the metallic character. You have learned in a group wise atomic size increases, as a result the shell increases. What happens to the metallic character? What happens to the metallic character? The metallic character increases top to bottom. Top to bottom means in a group wise. Group wise metallic character increases. How? Look at here. When you come down, the shells are far away from the nucleus. Right? The shells are far away from the nucleus. As a result, the outermost shell can be easily loses. So the metallic character increases because of the increase in size. What happens in a period wise? In a period wise, you can say that metallic character decreases. Metallic character decreases in left to right. Left to right. Okay. So when you talk about when you come to the right side, you can see that when the halogens, okay, the halogens are the most non-metallic type of elements. Okay, here the first two groups are the metallic, slightly more metallic elements. You can say that. Okay, and the next trend it is when you talk about it is electronegativity. Electronegativity. So what is electronegativity? I will show you some compound. HF. What is HF? Hydrogen fluoride. What is HCl? Hydrogen chloride. What is HBr? Hydrogen bromide. They are covalent compounds because they are formed by the sharing of electrons, and there is a peculiarity in these halogens. Fluorine, chlorine, bromine, they are all halogens. They form compounds with hydrogen. Okay. Then what is electronegativity? So if the compound HF forms, you can say hydrogen with 1 electron. Only 1 electron. Fluorine, atomic number 9. K is equal to 2. L is equal to 7. L is equal to 7. How many more required? There are one more electron is required to complete the octet, right? Yes. So one more electron is shared by the hydrogen. One more electron is shared by the hydrogen. So as a result, hydrogen automatically pull the electrons to the fluorine. Okay. So the group 17 members, when you talk about, they are all highly electronegative. They are all highly electronegative because they are ready to take only one electron to complete their octet. Okay. So in the 17th group, you can see fluorine is the more electronegative element. Out of the periodic table, in the periodic table, out of these elements, fluorine is the more electronegative element, and the electronegativity decreases from the top to bottom, but electronegativity increases from left to right. So generally you can say in a group means top to bottom, electronegativity decreases, but in a period means left to right. What happens? Left to right, electronegativity increases. Electronegativity increases. Okay, these are the important trends in the modern periodic table. And students, I just want to remind you one more thing when you talk about the trends. That is oxides, the nature of oxides. How it produces oxides. You know, in the left side you can see it is metals. In the right side you can see they are non-metals. So when you talk about the metals can produce basic oxides. But non-metals can produce acidic oxides. Can produce acidic oxides. How? Because metal oxides can combine with water and produce base. But non-metal oxides can combine with the water to produce acid. That is why they are showing two different natures. Okay? And so then today we are find up the session with the trends in the modern periodic table. Let me summarize the trends first. First, top to bottom, atomic size increases and the number of shells increases. And the atomic radius means the distance between nucleus and the outermost electron. They are increases. But left to right, atomic size decreases due to the increase in nuclear charge. Okay. And the top to bottom, what happens to the metallic character? Metallic character increases. But left to right, metallic character decreases. Okay. Top to bottom, electronegativity decreases, but left to right, electronegativity increases. Okay. And any other property? Valency. In a group wise, the valencies are same, but in a period wise, valency first increases, then decreases. And finally, metal oxides are basic in nature and the non-metal oxides are acidic in nature. Okay? Today we are finding up the session and we'll see you on next class. Thank you.